Alright, in this video I'd like to review the basics of equations and inequalities. Alright, an equation makes the statement that two expressions are equivalent, are equal. In other words, they represent the same quantity. Okay, and here is an example. Alright, so you have an x plus 7. That expression is equal, means it's the same quantity after you evaluate it as 2x minus 2. And so this is enough information that we can determine the unknown quantity x if we did not know it. Okay, so the trick is to change the equation so that it becomes obvious what the variable value is, all right, without changing the answer. All right. If suppose that I had two people on a seesaw and the seesaw was balanced, all right, it should be clear that if I put, let's say, a 5-pound weight on one side and a 5-pound weight on the other side, it would still be balanced. Okay, and then if I removed them again, it would be balanced just like it was before I put the weights on. All right. The idea is as long as I change the weight on both sides of a seesaw, it still remains balanced. Okay. Likewise, if I have two quantities and I alter both of those quantities by the same amount, if they were equal before, they're still going to be equal now. Okay. If that wasn't clear, let me write it out. So okay, 7 is equal to 7. That shouldn't be any argument about that. What if I doubled both of those quantities? Are both quantities still equal? What if I removed 4 from both of those quantities? Are they still equal? What if I added 2 to both? So the point is, you see what I mean? As long as you change both quantities, they're still the same if they were equal to begin with. Okay, now what I'm going to do with my expressions is use that powerful idea. Okay, so let me add 2 to both sides. And if I do, you can see that the right side got a little cleaner, didn't it? Okay. What if I now remove, even though I don't know what quantity x is, whatever it is, I can remove that amount from both sides. So this is kind of cool. You can actually add and subtract, multiply and divide even without knowing what a quantity is. So if I do that, that's going to make it look even cleaner. Okay, and it should be obvious from the red box what the mystery value of x is. Okay, so remember, this is the game that we play in algebra. We keep two expressions equivalent, and then we just massage it until it's obvious what the mystery value is. All right. Now, what about if I had, and let me say one more thing about this. So you can add and subtract anything you want, and it'll always be fine. You could multiply by anything you want, and it'll always be fine. You can almost divide by anything, and it'll be fine. There's only one number you cannot divide by. Okay, you cannot divide by 0. All right, so as long as you remember that caveat, everything else is fair game. Now, when you divide, if you were to divide by a variable like x, you have to make sure that value never had a chance of being 0, or you have to account for the possibility that it is 0. All right, but we won't talk about that too much. It's easiest to think about dividing numbers, and you can't divide by the number 0. All right. All right, what about inequalities? So what if I said, you know what, x minus 4 is bigger than 3? All right, now the same idea applies here. You can add, subtract, multiply, and divide except 0, and the inequality will still remain true. Let me show you why that is the case. Okay, suppose that I said that 5 was bigger than 1. I hope you believe me. All right. What if now I doubled both sides? Is 10 bigger than 2? Okay. What if I now added 2? Is 12 still bigger than 4? What if I chop them in half? Is 6 bigger than 2? All right, so you get the idea. It still remains true. Okay. Now there is and so I added let's see, I doubled, so I multiplied, I added, I subtracted. Um, let's see, what I doubled, then I added, then I divided. Okay, I haven't subtracted yet. So if I subtract, let's say 2, then all right, so clearly there's evidence I can do all the operations. Okay, now what gets problematic is the following: when you multiply or divide by a negative. Let's go back to the first one. 5 is bigger than 1. All right, so what if I multiplied both sides by -2? -10 is bigger than -2. Is that true? No, it is not. Okay? If you work this out, if you multiplied by a bunch of negative numbers and you divided by a bunch of negative numbers, you would see that they're always, always, always wrong. Okay? But if you flip the direction of the inequality, you can make it always, always true. So if I was to flip and write this, then that makes everybody happy. All right? So as long as you remember that that gotcha, then inequalities are pretty much like working with equations. All right, so like for this one, if I add 4 to both sides, then I can see that x is bigger than 7, and it should be clear that x could be a lot. Well, it could be, there's an infinite number of things it could be, but it could be 8, 9, 10. It can even be 100 divided by 2. If you love fractions, it could be 7.1. If you like decimals, all right, that's the idea there. Now let's do one using this that has this negative trap. So what if I had 7 minus x is less than or equal to 4? All right. Remember, if it's this way, that's greater than. This way is less than, and then you can have greater than or equal and less than or equal. And sometimes I say, think of it as an alligator. He wants to eat the biggest number. That's why you can think of this as a mouth. The mouth always points to the biggest, or wants to eat the biggest number. Okay? Or a fish, whatever have you. All right. Now, with teeth. Okay, so let's solve this one, and that will be the end of this video. So let's try, how about if we subtract 7 from both sides? So we get minus x is less than or equal to -3. Now we don't like the minus in front of the x, so we're going to multiply both sides by -1. When I do that, I'm going to remember to flip the direction of the inequality, and so that gives that much nicer, simpler inequality. All right?